Hi guys, today we will be doing electro-pneumatics, exercise 6, 7, 8 and 9. We've already done these 4 exercises in class, but I think these videos can help you with practice and clarify certain things that you didn't understand in class. So in this exercise, this is where you will learn the setup and function of a limit switch. It's a new component that is being introduced. So a limit switch, we have a limit switch and a magnetic switch on electro-pneumatics. Both of these switches are our end position detectors or sensors. They sense the front end and the rear end position in cylinders. So in basic pneumatics, we have roller valves, normally closed and normally open roller valves, as well as proximity sensors. Both the roller valve and proximity sensor, they are position detectors. So they detect or sense the front end or rear end position in cylinders. So in electro-pneumatics, same concept, just different components. How would you know when to apply a limit switch and when to apply a magnetic switch? You would know when to apply a magnetic switch if it is stated that you need a magnetic switch to sense, or a magnetic sensor to sense your rear end or front end position in cylinders. When I don't state anything about magnets, or if the sensor or switch is a magnetic switch, then you will have to use a limit switch. What is a limit switch? On FluidSIM, under general switches, we have a break switch, a changeover switch, as well as a make switch. A make switch is a limit switch. So this is a limit switch. Already I have set up my power supply, my 24 volts, my 0 volts, my compressor and my air service unit, because those are standard. You must have those. You must have your power supply all the time when you build your circuits, otherwise it's not gonna run. You will not be able to simulate. So I'm gonna teach you the difference between a limit switch as well as a magnetic proximity switch. This is a magnetic proximity switch. They both have the same function to detect and sense front end, rear end position in cylinders. Okay, so this particular exercise, we will first do it with the limit switch and then introduce a magnetic switch later. Okay. All right. So the description of the process states wooden boards need to be pushed out of a stacking magazine and into a mounting device. Right? A wooden board is pushed out of the stacking magazine with a slide after pressing a push button. So there's an operator that manually presses the push button to release the wooden boards through a slide, right? Meaning that when you press your push button, your piston rod needs to advance. It must go forward, it must extend. After reaching the front end position, which is the fully advanced position of the piston rod, the slide is returned to its initial position. So the slide, usually the slide returns, or the piston rod returns to its initial position whenever we use a single acting cylinder with a spring return. That spring return effect, it makes it to bounce back to its retracted or initial position. Or if we use a solenoid valve that has a spring return with a double acting cylinder, it would still be able to bounce back. So I'll demonstrate 3 scenarios and you will know which one to apply based on a particular scenario that you will be given in your test. Okay, so we're going to start with the scenario that requires a spring return. Okay, so in this exercise, it's indirect actuation. It's indirect actuation. So we have our relay, our solenoid valve. Before I even start building, I like to rename or to label. I like to label all the components that I have. So sol 0. And then from there, we know we need a changeover switch. Please don't make a mistake of choosing this changeover switch, because this is a push button. It is a push button changeover. It is not a changeover switch to represent your indirect actuation. So most of you, when your circuit doesn't simulate and you think you have inserted all the right components, just double check, because they might have the same name, they might slightly look the same, but their function is not the same. So the correct changeover switch to represent your indirect actuation is this one under general switches. So this changeover switch, we give it the same name as what? Our relay. So, right? And then we are told that we actuate or we advance this slide to release wooden boards through a push button. We use a make. I've already explained a lot of things previously, so I will not explain functions of other components that you already know how they work. So this is our push button. Always label your work, even though you are not programming on your circuit that flows through compressed air or that runs through compressed air. So you just have to label so that I know that this is your first push button, your second push button, and so on and so forth. So our basic circuit, indirect actuation, we have it. Let's try to make our work neat. Okay, so this is our indirect actuation. We need now our cylinder. Let us start with the single acting cylinder. Let us start with the single acting cylinder, and then all our solenoids, like I've explained previously, our valves. We use these solenoid operated valves, no longer pneumatically operated or mechanical operated, because why? This is we are done with basic pneumatics. Now we are on electro-pneumatics. So let us try our single acting cylinder. Okay, simulate. So when you click your push button, your wooden boards are released with a slide. When you release your hand, the slide goes back to its initial position, which is the rear end position. So let's read the statement that we are given. When wooden boards need to be pushed out of a stacking magazine and into a mounting device. A wooden board is pushed out of the stacking magazine with the slide after pressing a push button. After reaching the front end, the slide is returned to its initial position. So after reaching the front end, I click my push button, it has reached the front end. The slide and my wooden boards have reached the front end, which is my piston rod. After reaching the front end and I release my hand, the slide returns to its initial position. So most examples, I like to say a locking blade is released. It's pushing wooden boards into the conveyor belt. Once you release your hand from the push button, then it bounces back. Why does it do that? In this particular scenario, it does that because of what? Our single acting cylinder has a spring return. Our solenoid valve also has a spring return. So let us use a double acting cylinder. We're just exploring different ways of demonstrating the same scenario. So the same scenario, just different methods of presenting it. Okay, where are our solenoid valves? Valves. Okay, since this is a double acting cylinder, we use a 5-2-way, right? So let's use our 5-2-way. Do not forget to name Sol 0. Okay, so let's see if we can achieve the same results as the single acting cylinder. Okay, so I click my push button, power is supplied into the circuit, and wooden boards are being pushed out of a stacking magazine. I release my hand, the slide goes back to its initial position. So we were able to achieve what was required of us to do by presenting it in 2 different methods. So how are we able now to have this bouncing or spring effect that the piston rod or the wooden boards, they advance and retract at the same time? It is because of this spring effect that we have on our valve or our solenoid operated valve. So the previous example, the spring effect was coming from the single acting cylinder with the spring return as well as our solenoid valve. So we are able to achieve these 2 methods. We are able to achieve what was required of us by presenting it in 2 different methods. So in this particular statement, it's very important for you guys to really go through the statement, highlight to make sure that you have the keywords or the components that you need to use, you understand the simulation process, how it's supposed to run, and you understand the components that are supposed to be there to ensure that it runs as described in your description or your description of the problem or description of the process. So this particular statement, they didn't put everything together nicely in a paragraph form like I usually do, your basic pneumatics test 1. So we will then pick some of the components from our parameters or our general conditions. So we are only told that the push button, when it's pressed, it releases the wooden boards through a slide, and then once you release your hand from the push button and it has reached the front end position, your slide, then it will bounce back to its initial position. However, in this particular exercise, you are not required to build a circuit that will bounce back through a spring return or a spring effect. You need to ensure that you replace that spring effect with a sensor or with a position detector. So we take that information away from our general conditions. The cylinder's front end position needs to be sensed. Front end position, fully advanced position. So we don't need a solenoid operated valve with a spring return. Why? Because we are introducing a sensor or a position detector that will enable the slide to return to its initial position. So we'll use our solenoid valve without a spring. So we use our solenoid valve, and you already know that you're going to use what? A double acting cylinder, because a single acting has a spring return. So this solenoid operated valve does not have that spring return, and we want to achieve what a spring return does. Okay, so as you can see, this solenoid operated valve has two of these solenoid valves points to insert, or rather to configure our valve solenoid. This is our valve solenoid. So we're going to need 2 of these to configure them properly here. So I'll just copy and paste. My advice, if you're going to copy and paste, make sure you double check your labeling. because sometimes we forget to change the labeling. Well, it doesn't matter whether I'm going to start with my valve solenoid and my changeover switch or my relay. The structure doesn't matter. Whether I want to start with this or I want to start with the solenoid, as long as it's properly connected using the principles of FluidSIM, that if it's indirect actuation, your relay connects directly with your actuator, with your what? With your inputs, which is your sensor and your push buttons. And when it's direct actuation, it is directly connected to what? To not to your relay, but to your valve solenoid. So as long as you know the principles that when it's indirect, my valve solenoid is then connected to my changeover switch instead of my push button or sensor. So it doesn't matter whether you start this side or that side, but as long as you follow the correct principle of your connections on FluidSIM. So we have a relay, it means we need a changeover switch. We label it the same, relay 1, relay 1 as well on this side. Solenoid 1. So always start at 0. It just makes your work even easier. I also get to understand and to see where you started from push button 0 to push button 2 or to push button 3, because sometimes you have about 4 push buttons in one circuit. Okay, so your changeover switch directly connected to what? To your valve solenoid 1, or rather 2, since it's the second valve solenoid. And then instead of having a push button here, we need a sensor, which is a limit switch. We're going to take a limit switch, which is a make switch under general switches. This is our limit switch. We're going to name it sensor or switch, sensor 0. Or since it is detecting the front end position, then we might name it front end. Then whenever you have a limit switch or a make switch or a proximity switch, which is a magnetic proximity switch, you're gonna need a distance ruler to configure your distance ruler and label it exactly the same as your limit switch, as you would have labeled your limit switch. So you labeled your limit switch front end, your distance beginning. If it's front end, it means it's advanced position, which is 100, 200, right? So basically we are saying we're gonna click our push button. Our wooden boards need to be pushed, it needs to be pushed through a slide. Let us read our question again. So when a wooden board is pushed out of a stacking magazine through a slide, so it must be pushed out of the stacking magazine through a slide. So we're going to take our piston rod as our slide. So this slide, it will advance pushing the wooden boards out of the stacking magazine. And then this limit switch, we are programming it that once our slide has reached its fully extended position, which is 100, 200, it needs to return automatically into its rear end or initial state. Let's test it out. Okay, you saw that. I click my push button, current flows, compressed air is flowing. My slide has extended, pushing the wooden boards out of the stacking magazine. I release, check the front end. There's an arrow there on our front end limit switch, which shows that the sensor is on. The sensor is on because why? Our slide has reached its extended position. I release my hand, it returns to its initial position. So we're able to achieve the bouncing back effect, the advancing and retracting effect at the same time without any spring return, but through programming our sensor using our distance ruler. So guys, I hope you understand question 6, and you know that you don't have to cramp, but to actually understand the function of each component so that you know which one to apply on which, under what circumstances or scenarios. Okay, so let's work on exercise 6. Exercise 7. Exercise 7, we will be familiar with an AND operation or an AND gate, right? And still we are using indirect actuation. So in your test, I don't think I'll ever give you a test where I need you to build a circuit through direct actuation. Maybe when we are doing lab 3, which could be robotics or electro-pneumatics with PLCs, then I might give you a circuit. I might say develop a circuit that has direct actuation, but here all the tests that I'm going to give you, lab 1, lab 2, usually it's indirect actuation because it's more complex than just direct actuation. Okay, so it's indirect actuation still, and what's the new component that has been introduced? It is an AND operation. So beverage crates are checked for completeness with the help of an inspection unit. Incomplete crates are pushed off of the roller conveyor by pressing a push button. Problems occur repeatedly with the setup used thus far. Right? The push button is not pressed long enough, and as a result, the single acting cylinder doesn't advance to the front end position. So the ejected beverage crates become jammed in the ejection area. Develop a controller with which this problem can be eliminated. So we're going to try to present both scenarios, which is the current process or the current problem that this company is encountering, and then we're going to design an improved circuit without the failures or the jamming issue that they have. So the description of the process: the cylinder of a piston rod should advance as soon as a push button SF1 is activated. After the piston rod reaches the front end position, advance position 100 to 100, and activates a limit switch, it should be retracted automatically. So this, it sounds the same as the previous exercise because we were using a limit switch to detect the front end position, and the slide would return to its retracted position automatically. So this statement is quite similar as the statement. Wooden boards are pushed out of a stacking magazine with the slide after pressing a push button. After reaching the front end position, the slide is returned to its initial position. So it's just that they didn't add this general condition here, but you consider it when you are developing your circuit. The cylinder's front end position needs to be sensed. So it's like this question 6 has been revised in question 7. It has been upgraded here. It makes a lot more sense here. However, we need to take in consideration also what this statement that we have been given under description of the problem. Okay, so let us check the general conditions. You have a double acting cylinder that has to be used. Control of the cylinder will be executed indirectly with push buttons and electromechanical limit switches. Okay, excuse me. So from this statement, I can tell that I need 2 limit switches. I need 2 limit switches because it says because it says control of cylinder will be executed indirectly. I know it's indirect actuation. I need a relay, a valve solenoid, my changeover switch, and the push button, right, to start my process. However, control of the cylinder will be executed indirectly with push buttons. Okay, with push buttons. So we have two push buttons, but we haven't figured out which one is for what. Okay, but we know that to control the cylinder, we need these push buttons, or this push button, and electromechanical limit switches. So from reading this statement, even though it's not put up together nicely, okay, let's continue. Advancing can only be started when the piston rod is in its rear end position. Okay, yes. So we need what? Two limit switches. We need what? Two limit switches. One limit switch, it's going to detect the rear end position. It's going to detect the rear end position of the piston rod. The other switch is going to detect the fully advancing position of the piston rod. How do we know that? Okay, well, we are told that advancing can only be started when the piston rod is in its rear end position. So when it's 0 to 0 and we click the push button, it will be able to work. So this is where our end operation also comes in, because we have a push button and the switch. For this process to happen, both of these, we have a condition that needs to be activated, or we have a condition that needs to be achieved, which is detecting the rear end position of the piston rod. And then how do we know that we need another second push button? We are told here that after the piston rod reaches the front end position and activates what? A limit switch, it should be retracted automatically. So we need a limit switch for advancing, we need a limit switch for retracting. But when we advance, the limit switch, it is just a condition that works hand in hand with a push button. Okay, so let us first start with what I've highlighted, build it, check our statement if we have achieved what we are required to do. So I'll just keep starting over with building my circuits so that you don't get confused. Compressor again. Rotate again to 180 so that it's easy for you to join. Okay, so this is what we have. Okay, I did mention that the rest of the exercises we will be building them on they are indirectly actuated. Name your work quickly. We know when we have a relay, we need a changeover switch. Give it the same name. Valve solenoid. Okay. Then we need what? A push button. Start PP 0. Okay. Okay. So the only difference between this exercise and the previous one, we have our push button, indirect actuation, relay, solenoid valve, changeover switch. To actuate, we don't need any sensor or position detector, right? We only need a sensor or position detector for retracting and not for advancing. So here we need that position detector or sensor, which is our limit switch, to advance. So we go to our make switch. Since our make switch is an actuator, we connect it directly to what? To a relay. It is our input. So this, we are told that it needs to detect the rear end position. So we call it rear end. Then, so that I don't forget, this is what I always do. I insert my cylinder and then my distance ruler, rear end, then I configure 0 to 0. Then front end, we're also going to need it for what? For our piston rod to automatically retract when it reaches its fully advanced state. Right. So what do? We take another limit switch or make switch that will detect your front end position. Give it the same name. Double check on your ruler if you've given it the same name. Front end is 100 to 100. Cool. This is what? It's our input or our actuator. It is directly connected to what? To our relay. Copy. Then we're gonna say it's a relay. Okay, we're gonna give it a name. All right, before I start connecting our components that we use to retract the piston rod, we're gonna finish first our components for advancing the piston rod. So our relay 0 connects with this changeover 0 for what? Our push button. And then this rear end limit sensor or limit switch that senses the rear end position, it is connected to a relay. However, you can't have a relay and you don't have a changeover switch, because those two are a pair. They go hand in hand. So what do you have to do now? You must get your changeover, give it the same name as your relay under your rear end detector or switch or sensor. So because you already have relay 0 that exists, we're gonna say this is relay 1. Please do not skip from saying relay 0 and then here you give me relay A or B or Z. Everything that you do, please guys, it needs to make sense. Okay. So your changeover, you must give it also the same name. So it's going to be real 1. This, usually it connects directly to a valve solenoid, right? However, the second valve solenoid, it would be for actuating our piston rod to retract and not to advance. So maybe let me leave this hanging for now, and then put our front end limit switch, get a valve solenoid, gonna call it 1. Our relay here will say it's 2 because we already have 1 and 0. Then we copy, okay, let me not confuse it, take a changeover switch, relay 2. Okay. All right. So this solenoid valve, we connect it to this relay. I'll explain as we go. Right. So this connection makes sense. We have our front end limit switch. We've connected it exactly as we've connected it even on exercise 6, right? For it to bounce back to its retracted end position. So let us finish building this side. We need our valves. We're gonna take a solenoid operated valve without a spring return. Without spring return. Sol 0, Sol 1. So Sol 0 is for this side, our advancing side. That has our push button and our limit switch. And then this Sol 1, it is for our retracting process. So it is for our second limit switch that detects the fully advanced position of our piston rod. So what do we do with this changeover switch? Because we can't have a third valve solenoid, because all the solenoid operated valves, we only have 2 points for our solenoid, our valve solenoid configuration points. So because this limit switch, it's a condition for our piston rod to advance. For our piston rod to advance, we use this push button, right? So to add this condition, we then connect these two in series. Because when you connect two inputs in series, it means whether it's inputs or outputs, when you connect them in series, it means it's an AND operation. When you connect them parallel, it means they are an OR gate or OR operation. So our changeover switch switches, both of these are powered by this valve solenoid, right? By this valve solenoid. And then take this second valve solenoid, or this side as your retracting side and this side as your advancing side. So this limit switch, we use it to advance. Hence, it's going to be connected directly to this solenoid 0. Because everything this side, it falls under what? Under the advancing side or the advancing process. So there's nothing deep to it, guys. This is a principle or a method on how to present your AND operation when you have two actuators that you need for the same process. So this is how you connect them. I hope I am clear enough. So let us test our circuit if it runs exactly as described. So we click our push button once. So I click my push button once, it advances and retracts. I click, advances and retracts. I click again and release my hand, it advances and retracts. So let us check if we were able to build according to the question. So the question says the cylinder of a piston rod should advance as soon as the push button is activated. After the push button reaches the front end position and activates a limit switch, it should retract automatically. It does that. Where do we get the rear end limit switch? This side. Advancing can only be started when the piston rod is in its rear end position. Excuse me. Right? So we were able to achieve these requirements for this question. We're even told that we have a double acting cylinder, but even if we weren't told in a test, we'd figure that out, because you know when we have a 5-2-way valve, it cannot be connected to a single acting cylinder, right? And this question requires you to retract without a spring return, so you don't need a single acting cylinder. That's how you are able to pick up which component to use in which scenario. Okay, so I think we were able to achieve this Now let us check the failure. If I had asked you to give me two circuits, develop two circuits. So the circuit that we've just developed now, it is the improved version, right? And the one that, as you see, it's written, develop a controller with which this problem can be eliminated. So what we have built or developed, it is the improved circuit that eliminates the problem mentioned above. So what is the problem mentioned above? Beverage crates are checked for completeness with the help of an inspection unit. Incomplete crates are pushed off of the roller conveyor with the setup used thus far. The push button is not pressed long enough. As a consequence, the single acting cylinder doesn't advance to the front end position. As a consequence, the single acting cylinder doesn't advance to the front end position. The ejected beverage crates become jammed in the ejection area. So let us check, what does it mean, the ejected beverage crates become jammed? How do you present this? Actually, I don't know why it's not highlighting, but okay, it's fine. Yeah, that's what I wanted to highlight. So let us develop our circuit to present a single acting cylinder. We know for sure we are using that. We are using also a push button, and we want to develop a circuit that doesn't advance to the front end position, but it becomes jammed. So when it says it becomes jammed, it means that it advances, but it doesn't fully advance. So the piston rod, it is not fully extended out of the cylinder, single acting cylinder. So usually this case would be presented as a continuously running process, that it extends, retracts, but it doesn't fully extend, it doesn't fully retract. So there's a glitch there. So that's another method of presenting a glitch or a problem, depending on the details given in your statement. So we will try to check if we are able to present this as a front end position that only advances but not enough, and the one that advances and retracts but it doesn't advance enough, long enough, or it doesn't also retract long enough. So let us try building those. Okay, our basic. Okay, so we present this as indirect actuation as well. Correct, changeover switch. Great. And we are told we are using a we are using a single acting cylinder. Single acting cylinder, solenoid operated valves. make sure you pick correct push button. Okay, incomplete crates are pushed off the conveyor by pressing a push button. Problems occur repeatedly with the setup used thus far. The push button is not pressed long enough, and as a consequence, the single acting cylinder doesn't advance to the front end position. The ejected beverage crates become jammed in the ejection area. Okay. Okay, guys. Exercise 7, so that it doesn't confuse you. The current state, which has a problem, which I've highlighted in yellow on your question, I think let's just leave it as it is, and we are required to only present the improved version. So we are required to only come up with the improved version. So the circuit that we've built previously, before we try building the one with the single acting cylinder, it's the one that is required for this exercise. So we disregard the failures because we are not required to present 2 of these circuits. Okay. And I will never give you, or let's say this year, I won't give you any test that requires or that has this kind of failure, which is jamming. Usually the kind of failures that I like to give students are it runs continuously and it doesn't stop, and you need to, yes. So excuse me. So for your exercise 7, you are required to detect your starting position, or you sense your rear end position as well as your front end position. Rear end position, your retracted end position, which is 0 to 0. Front end position, fully advanced position, which is 100 to 100. So we are able to achieve that. The only difference between this exercise and exercise 6 is that exercise 6, it only requires you to sense only one position, which is the fully advanced position, so that it automatically bounces back. Okay. So guys, the video is too long. I don't want it to be over an hour explaining 2 exercises. What I'm gonna do is I'll record another exercise, another video that takes 2 exercises, which is 8 and 9. All right.